So I want to talk to you now about functions. This is section 1.3, and this makes sense because for most of us, the first time that we heard about relations was with respect to functions. So this is going to have a few more suggested exercises than normal. So 3, 5, 7, 15, 17, 33, and 35. So functions are going to be one of the main focuses of this class. So it's very important that you get this stuff nailed down early. I don't want you to be confused about what a function is or how a function works in the coming weeks, because that's gonna cost you a lot of time. So if you've been paying attention to the class but kind of thinking about slowing down or maybe doing something halfway, don't do this section halfway, please. Okay, so of course we're going to talk about functions. We're going to talk about the vertical line test, which probably a lot of you have heard of. We're going to talk about domain, and we're going to talk about range. And spoiler alert, there's a bit of a surprise when it comes to range. So I would like for you to work through examples 3 through 5 in the book. So I'm just going to dive right into it. So a function is, so let's say a function f from a set D to a set E is a correspondence or mapping. We might say mapping that assigns each element x of D to exactly one element. Whoa. Yeah, having a hard time writing. Exactly one element y of E. Now this I'm using, again, as we often do with quote-unquote definitions in this class, is I'm using a little bit rough language here. So I'm saying it's a correspondence or a mapping. So a function is a way of relating, hence the term relation, elements in one set to elements in another set, or it could be the same set. The elements in the set D to elements in the set E, not saying whether or not D or E are the same set. Now, we often write this or express this as y equals f of x. So here x is the input to a function and the output is y. All right, so this is how we often write things. So this is kind of the output, and x is kind of the input. And that's how we tend to think of things. Now, the set D is called the domain. I don't know why I capitalized that. Of f. The subset of E that is mapped to by f is called the range or image of f. Now you might say, oh no, E is the range. Okay, that's actually technically incorrect. E is something we call the target. So just as a side note, E is actually called the target. We could also call it the codomain. And I don't want to get too bogged down with this, but the thing is, if I tell you I have a function f and it maps real numbers to real numbers, so it takes a real number as an input and it gives us a real number as an output, then we would think, oh, the domain is real numbers and the range is real numbers. And that would seem all right. But we know that real numbers happen to also be complex numbers. which means we could also say, by that notion, we could also say that the complex numbers are the range. And so this is a problem. So we've actually defined the range to be the subset of that set that is attained or is mapped to by f. And if this distinction doesn't make a whole lot of sense yet, don't worry about it too much. It's not going to play a huge role in what we're doing in this class. But I do want you to be aware of it because this is a distinction that's I find often lacking in earlier preparation, and it can get you into trouble later on. Okay, so moving on. So the vertical line test, which we'll be using, call it VLT, says that a set of points in the coordinate plane correspond to the graph of a function if and only if, so IFF you'll recall is if and only if, so it's not misspelled, that's if and only if. It's a separate way of denoting things. We say IFF, and that's just shorthand for if and only if. So if and only if any vertical line touches the graph in no more than one point.